So the next one we have is our implicity function. Implicity functions. This is another method. Implicity rule functions. So we'll call it implicity differentiation. You see in this case, let me just give you the simple logic of that. It's like if I'm differentiating x, it will be dx dx. But if I'm differentiating y, as usual, it's going to be what? Yeah, dy dx. And the thing is, implicity is different from the other function because it's even very easy for you to identify that, okay, this question is implicit, is the other method, because at that time, or at that particular problem, you will have let's say how the question will look like. We tell you that, of course, you need to differentiate x, at the same time you need to differentiate y. So meaning, let's say for example, say differentiate, find the derivative. They say find the derivative of the following. Let's say we have a problem like this: 1 x squared plus y squared is equal to 1, 2x cubed, 5y4, 7 is equal to 3x4, let's say 7y2 plus 8. And let's say in the third one, let's say we have x squared plus, let's say we have x4 y3 equal to 2x squared y5. You look at this, so you can see the way the problem comes is different from the other functions. Yeah, fine. So how are we going to go about it? Note, if you are differentiating x here, we need to differentiate x. At the same time, we need to differentiate y. So if you are differentiating x, of course, it's going to be dx dx, and that one is 1. And if you are going for y, it's going to be dy dx. So the first one is very simple and straightforward. First one, they say x squared plus y squared is equal to 1. So I want to find the value of this. So differential of x squared, the differential of x squared is nothing but 2x. You remember that. And then we have the x dx plus differential of y squared. What are we going to have? Yeah, 2y. Then if I have differential to y, of course, I will have dy dx. Then differential of 1, of course, is going to be 0 because it's just a constant. So now, dx dx is 1. So that means here we have 2x plus 2y dy dx is equal to 0. So I can make my dy. I want to make my dy. What I'm looking for, I want to make my dy dx at the subject. If I collect the like terms, so here we have 2y dy dx is equal to, this is 2x. So when the 2x comes here, we have minus 2x. So since I'm looking for this, divide both sides by 2y, divide both sides by 2y. So if this cancel this, we have dy dx is equal to, you can see 2 even can also cancel 2. What we have left is a minus x over what? Minus x over y. Can you see that? Yeah. Let's look at the second one. They said 2x cubed plus 5y raised to the power of 4 plus 7 is equal to 3x4 plus 7y squared plus 8. 2x cubed 5y4 plus 7 is equal to 3x4 plus 7y squared. Don't mind how they put the problem. Just follow it using the same pattern. So we differentiate x, at the same time we differentiate y. So from here, I know differential of 2y raised to the power of 3. That is going to give us what? Yeah, it's going to give us 6x squared. Then we have the x dx plus differential of 5y4. What are we going to have? Yeah, 20. That's going to be 20 y3 dy dx. Then this is constant. Differential of 7, we are going to have 0. Differential of 3x4, of course, we have 12x cubed dx over dx. So plus differential over 7y squared, of course, we are going to have 14y dy over dx. Then differential of 8, that one is nothing but 0. Can you see that? So now the next step is those who have, So now, you know, if I have this is 1, so I can write this as 6x squared. So the one we have is 20y cubed dy dx. So here too, the x dx is 1. What I have here is 2x cubed. Then we have 14y dy over dx. So the next step is the one with dy dx one side, the one without dy dx to the other side. So if you look at it, you can see here we have dy dx. At the same time, here too, we also have dy dx. So those who have dy dx one side, the one without dy dx to the other side. So here I can have 20y cubed dy dx, the one that we have here. So I want to bring this one to come to this side because we have dy. So look at it. This one have dy dx. This one also have dy dx. So the one with dy dx one side, the one without dy dx, just like this and this. So 20y cubed dy dx minus 14y dy dx is equal to, what we have left here is 12x cubed. So this is plus 6. So when the plus 6 comes here, we are going to have minus 6x squared. Can you see that? Yeah. So now what do we have in common here? We can see what we have in common here is dy dx. So what I have here now is 20y cubed minus 14y is equal to 12x cubed minus 6x squared. Can you see that? So now, since I'm looking for dy dx, I can make my dy dx at the subject. How will I make at the subject? Divide all through by the coefficient of dy dx. That is, divide all through by 20y cubed minus 14y. Can you see from here? Help me to check. 14y. Can they see from there? No. They can't? Yeah. So that means I have to, can you see from here? Yeah, now they can see. From here, right? Yeah, so that means I need to clean the last part. Yeah. So that's why we have our manager here. They are the one taking care of us. So now, can you see this one? Yeah, they can. Yeah, good. So let's just move from there. Now from here we have 20y cubed dy dx minus 14y dy dx is equal to 12x cubed minus 6x squared. So now if you check here, what do we have in common from here to here? You can see I have dy dx. I will later factor out if another thing, but therefore to factor dy dx, what I have left there is 20y cubed minus 14y is equal to 12x cubed minus 6x squared. So now I'm looking for this, which is divide all through by 20y cubed minus 14y, 20y cubed minus 14y. So if this cancel this, we have dy dx. So now let's check again. Do we have anything in common at the denominator? Yes, of course we have. 6 can go. 6 is common. At the same time, we also have x squared in common because, you know, this is x cubed, this is x squared. So that means if I do that, how many 6 can we get in 12? We are going to have 2x left here. Then here we are going to have minus 1 since we have already factored out 6x squared. So let's check the denominator 2. What do we have in common? You can see this is 14. This is 20. One number can go in 2 without remainder. 2 can go. So this is y cubed. This is y. Of course, y is also common. So 2 in 20, we have 10y squared because we have already factored out 1y. Then what we have later is a minus 7. Even you can still go for that. 2 here 1, 2 here is 3. So here I can have 3x squared, 2x minus 1 divided by y, then 10y squared minus what? Minus 7. So you can see how we factor out. So you just have to know how to factor out the numbers. So let's see the next example, the last examples that we asked to do here. Let's see how we are going to go with this. They said, you can see the only difference we have in this question is we have x and y together, but you don't need to perplex. That's why we have Medici Academia. So we try to break the problem to the simplest term. You see, we have x and y together. How are we going to go about it? You say, how am I going to lift x? No. What you do is, if you are considering x, you cover y. And if you are considering y, you will cover x. It's not as if you are going to remove it. you cover it. You call it cover up method. So let's do it. Differential of x squared, I know we have 2x, and I told you if I'm differentiating x, we have dx plus. Now, I want to firstly differentiate x now, I'll cover y. Differential of x4, I know we have 4x cubed, right? Then I cover y, meaning I'll just, without touching y, that's the meaning. Then we have the x dx plus the same problem respect to y now. It's two. You firstly do it respect to x, then followed by respect to y. Or if you like, respect to y, then respect to x. So now I cover x now, meaning I did not touch x. Differential of y cube, we are going to have 3y squared. And mind you, whenever we differentiate to y, we know we are going to have dy dx. You get that? Good. The same thing applicable to this side. This 2 is for the two of them, not only for one. Now, differential of x squared, of course, and we have, or if you like, you can go along, two can go along together with the two of them in separate ways. Differential of 2x squared, definitely we are going to have 4x, then I did not touch y, then we have the x dx. Let me explain myself again. Differential of 2x squared is 4x, right? So since they are together, I did not touch y, we put y here, then we know whenever we differentiate x, we are going to have the x dx. Now, turn of y now. Differential of 2y5. This is what we have there. 2 raised to the power of y5. 2y raised to the power of 5. Differential of this, we are going to have 10y4. 10 raised to, you get that? 10y raised to the power of 4. So here, I did not touch y. So what I have for, I have x rather. I have x squared. So I have 10y raised to the power of 4. Then we have dy dx. So now, let's now arrange now. When we have dx dx is nothing but 1. So here I have 2x plus. So here, what that we have here is 4x cubed, y cubed. Dx dx is nothing but 1. So I can arrange this one. This one can be 3x4 y squared dy dx is equal to this one too. This 4x y5, because dx dx is 1. Then I can arrange this one too as well. That is 10x square y4. Then I will have dy dx. So what is going to be the next step? The one with dy dx one side, the one without dy dx to the other side. So here I can have this one to be. You can see I have dy dx here. So that means I will have 3x raised to the power of 4 y square dy dx. So this is another one with dy dx here. This is positive. If it come here, we have minus 10x square y raised to the power of 4 dy dx is equal to, now here you can see what we have left here is 4x y raised to the power of 5. Now, so you can see this and this don't have anything. So I have minus 2x because this is positive. When it comes here, we are going to have negative minus 2x. So this one too, we have minus 4x cubed y cubed. You get that? So now, as usual, what do we have in common? We have dy dx is common. If I factor it out, that means that we have dy dx, or factor out dy dx. So what I have left here is 3x4 y square minus 10x square y4 is equal to, now all this, we have 4x y raised to the power of 5 minus 2x minus 4x cubed y3 y raised to the power of 3. So now the next one is to make our dy dx at the subject, since that what we are looking for. If I make that one at the subject of the formula, so that is defined all through by this value. So that means there we have dy dx is equal to 4x y raised to the power of 5 minus 2x minus 4x cubed y cubed divided by, now what we have here, what we have is 3x raised to the power of 4 y squared minus 10x squared y raised to the power of 4. So now we can see factors. You checking what we have at this side and checking what we have at this side. So let's check if we have anything in common at both numerator at the same time denominator. It depends on how you leave the result. If the result doesn't require simplifications, you can leave it like this. But if you see the result and you see that the answer is not there, so that we need to factorize. So let's check from here to here. From here, do we have anything in common? If you check, we have 4 here, we have 2, and we have 4. Meaning 4 can go into 2 of them without remainder, so I can pick out 2. At the same time, do we still have anything in common? Let's check. We have x here, there is x here, and there's x. Of course, x is also common. I can bring that now also. Now, but if you look at the state of y, we have y here, there is no y here, so we don't need to factor out y. So there is y here also as well. So now 2 in 4, and we have 2. You know, we have already factored out the x. So then here I have y5 minus, I've already factored out this. I have 1, and here 2 in 4, and we have 2, x in s cube, and we have x squared and y cube, all divided by. So let's check denominator 2. Do we have anything in common? Yeah, we have x squared in common, and we also have y squared in common as well. So if I do that, what do we have in common? You know, 3 will remain here. This is x4. I've already factored x squared, so that means that we have x squared here. Then I've already factored out the y squared minus, this is 10. I've already factored out this, so what we have left is y squared. So those are the ways of solving a problem related to implicity functions. So now let's take a look at another problem or another functions. We call it an inverse function.